What if I told you that there is a cosmic monster lurking in the distant universe, so massive and powerful that it can bend the light of other galaxies around it? And what if I told you that we have just captured its most detailed portrait ever, thanks to the incredible vision of the James Webb Space Telescope? Well, that's exactly what we are going to talk about in this episode. Meet El Gordo, the largest and hottest galaxy cluster ever seen at its distance or beyond, and discover its secrets and mysteries with the help of Webb's infrared eyes. El Gordo, which means the fat one or the big one in Spanish, is a fitting nickname for this colossal galaxy cluster. It is located more than 7 billion light-years from Earth, which means we see it as it was when the universe was only half its current age. It has a mass of about 2.1 quadrillion times that of our Sun, which is equivalent to the mass of 3 million billion Earths. It is also extremely hot, with a temperature of about 100 million degrees Celsius, hotter than the core of the Sun. But El Gordo is not just one big blob of galaxies. It is actually composed of two separate galaxy subclusters that are colliding at several million kilometers per hour. This violent merger creates a huge shock wave that heats up the gas between the galaxies and makes it glow in X-rays. It also produces a powerful gravitational field that acts like a giant lens, magnifying and distorting the light of more distant galaxies behind it. This phenomenon is called gravitational lensing, and it allows us to see objects that would otherwise be too faint or small to detect. But how did we find El Gordo in the first place? Well, it was not easy. El Gordo was first discovered in 2012 by combining data from two ground-based telescopes, the Atacama Cosmology Telescope, ACT, in Chile, and the South Pole Telescope, SPT, in Antarctica. These telescopes detected El Gordo by measuring its effect on the cosmic microwave background, CMB, which is the faint afterglow of the Big Bang. El Gordo's hot gas scatters some of the CMB photons, creating a distinctive signal known as the Sunyaev-Zeldovich effect. Later, El Gordo was observed by other telescopes, such as NASA's Chandra X-ray Observatory and the Hubble Space Telescope, which confirmed its massive size and revealed its complex structure and dynamics. However, these observations were limited by their wavelength range and resolution. They could not capture all the details and subtleties of El Gordo and its surroundings. That's why El Gordo was selected as one of the first targets for the James Webb Space Telescope, as it has several advantages over previous telescopes for studying El Gordo. First, it can observe in infrared wavelengths, which are ideal for seeing through dust and gas that block visible light. Second, it has a much larger mirror, which gives it sharper vision and a deeper reach into space. Third, it has a suite of 4 sophisticated instruments that can perform various types of observations, such as imaging, spectroscopy, and coronagraphy. One of the most striking features of El Gordo, revealed by Webb's image, are the thin one and the fishhook. These are two long and curved arcs of light that stretch across the cluster. They are actually images of background galaxies that have been stretched and distorted by El Gordo's gravity. The thin one is located near the center of the cluster, where the two subclusters are colliding. The fishhook is located on the left side of the cluster, where one of the subclusters is moving away from us. The thin one and the fishhook are not only beautiful to look at, but also very useful for studying El Gordo and the distant universe. By measuring their shapes and colors, astronomers can learn more about the mass and structure of El Gordo, as well as the properties and evolution of the background galaxies. For example, they can estimate how far away they are, how old they are, what kind of stars they have, and how fast they are forming new stars. One of these background galaxies is particularly interesting, El Anzuelo, the fishhook, which is located at the tip of the fishhook arc. This galaxy is very distant. Its light took 10.6 billion years to reach us. It is also very red, which means that it is dusty and has a high redshift due to the expansion of the universe. Webb's image shows that El Anzuelo is a disc-shaped galaxy, about 1/4 the size of the Milky Way. Webb's spectrograph also reveals that El Anzuelo has a low rate of star formation in its center, which suggests that it is undergoing a process called quenching, where the gas supply for new stars is depleted or prevented. Another background galaxy that caught Webb's attention is La Flaca, the thin one, which is located at the end of the thin one arc. This galaxy is even more distant than El Anzuelo. Its light took 11 billion years to reach us. It is also very faint and small, which makes it hard to see without the help of gravitational lensing. Webb's image shows that La Flaca is a blob-like galaxy, about 1/10 the size of the Milky Way. Webb's spectrograph also reveals that La Flaca has a high rate of star formation, which suggests that it is in an early stage of its evolution. So what can we learn from this image? Well, a lot, actually. This image is not only a stunning snapshot of El Gordo, but also a window into the history and future of our universe. By observing El Gordo with Webb, astronomers can test some of the fundamental theories and models of cosmology, such as how galaxy clusters form and grow over time, how dark matter and dark energy shape the large-scale structure of the universe, and how gravitational lensing can reveal hidden aspects of reality. For example, El Gordo poses some challenges for the standard model of cosmology known as lambda CDM, which describes how matter and energy interact in an expanding universe dominated by dark energy. According to this model, galaxy clusters like El Gordo should be very rare at such early times in cosmic history, and their collision velocity should be much lower than observed. Therefore, studying El Gordo can help us understand if there are any missing pieces or alternative explanations for our current understanding of the universe. Another example is the discovery of a single red giant star in El Gordo's image, nicknamed Quilur, the Quechua word for star. This star is located near the center of the cluster, where it is magnified by about 100 times by gravitational lensing. This is the first time that Webb has detected a single red giant star beyond 1 billion light-years from Earth. Previous observations by Hubble have only found lensed blue supergiant stars, which are much brighter and rarer than red giants. Red giants are common stars that have exhausted their hydrogen fuel and expanded to a larger size. They are important for studying stellar evolution and nucleosynthesis, as well as for measuring distances in the universe. Thank you for watching this episode about Webb's amazing image of the El Gordo galaxy cluster. I hope you enjoyed learning more about this cosmic monster and its secrets. If you did, please like, share, and subscribe for more videos like this one. And don't forget to leave your comments and questions below. See you next time.